Hi everyone, I'm Lauren Pisanik, an OpenSciEd teacher in New Jersey. In this video, we are looking at the investigation and key moments of Lesson 12. So let's get started. First, let's think back to how we got here. We conducted a series of investigations and demonstrations in Lesson 11 to help us figure out why water droplets and ice crystals aren't falling all the time. So we figured out that the more mass something has, the greater the force of gravity pulling down on it, and that moving air exerts a force on objects in its path. And we figured out if those forces on the object are balanced, the object's going to stay suspended in the air. But the forces are no longer balanced, the object will move upward or downward. So we're wondering what causes more of this lift force in one cloud versus another. And that's the question we investigate in Lesson 12. Here's our lesson at a glance. Lesson 12 is a 2-day lesson with a teacher demonstration and a student investigation planned for day 1. And we'll talk more about that later. You need to budget about 60 minutes to gather and organize the materials for your student lab group, as well as for the initial teacher demonstration. The really helpful Lesson 12 teacher demonstration video goes over both of these pieces, both how to set up and run the demonstration and also some tips for doing this with the investigation for small groups. You will want to really think through the material and lab management for this investigation, and we'll talk through some tips and tricks later in the video. The lesson snapshot gives us the overview of the 2-day lesson and the 2 big chunks of this lesson. So let's zoom in on day 1. In the first chunk of the lesson, we navigate in by remembering our ideas about what might cause stronger updrafts and how we could investigate this. So we use water in place of air, and we map the elements of our system to the real world. This lets us observe fluid behavior with thermal energy added in to actually see the convection. And then we'll collaboratively design an investigation and brainstorm ideas to test different conditions in small groups. In the next big section of the lesson, we report out on our results and we make sense of the data, and then we gather in a scientist circle to conduct a building understandings discussion and update our progress trackers. This chunk of the lesson helps us figure out that our evidence shows that the greater the thermal energy input, the stronger the lift or convection currents. So during this lesson, we're building on the model of convection that we originally introduced in Lesson 6. So the students are extending that model by gathering evidence now that the greater the thermal energy input, the stronger the convection currents. They also figure out that some winds are the result of this convection. So we leave this lesson ready to put all our pieces that we figured out together, though we're still wondering about different hail sizes. So we'll tackle that last piece in Lesson 13. There are several key moments in Lesson 12. In Part 2, this is right at the start of the lesson on day 1, we introduce students to the use of liquids to help us understand and visualize currents. So scientists have found that many aspects of how currents move are similar in both gases and liquids. And for example, one of those is that they both exhibit similar patterns related to convection. So we help the students understand we can use a liquid to help us understand what's going on with the air. So we'll have the experimental system already set up and visible to the class. And then as a class, we'll map the elements of this experimental setup to the real world. This is a really important step in the practice of developing and using models. And it's helpful in the sense making for the kids. Really, really useful later when we're interpreting our results to return to this element map to make sure that we're taking what we see in our experiment and being able to use that to explain what's happening in the real world. In Part 4, it's time for us to move into designing our investigation, and we can use the convection investigation plan handout to help guide this. So you will go through condition 1 as a class based on the teacher demo, and more tips for this demo are coming later. So in this part of the lesson, we make a class list of possible variables to test. And then what I do is I use that as a checklist to let groups pick what they want to test. So I try to spread it out among the groups. It's okay if multiple groups test the same variable, but it's great if we have more ideas and we can test a variety. Keep using independent, dependent, control terminology here. And then once decisions are made, small groups will continue finishing the plan on their own. So the lesson snapshot moves from this right into conducting the investigation on day one. I have found that to be way too rushed for my kids. So rather, I spend time with this designing and planning piece and then set the students up to conduct the investigation first thing on day two. There's a lot to manage in this investigation. If each group is testing something different, it just helps me to have time to gather the materials and make changes as needed. So that's something to keep in mind. On day two, after the students have conducted their investigation, in part 7, the students are going to report out the results with their group and make sense of the data. And to do this, they're actually going to model the movement of air in their condition. So we'll give them this handout or this model to draw what they noticed, but now putting it on top of a real world, a screenshot of air. This is a great time to assess student understanding, being able to walk through and see them. The kids are going to have to synthesize what they see across all the different groups in here. So doing this in a way that's visible, either having the kids do it on big whiteboards or having them do it on small pieces of paper and then through a gallery walk, lets them then be able to see what other students have figured out. Okay, let's think about some of the material tips we have for this. So in both parts 2 and 3, right, we're referencing an experimental setup and then we are running a teacher demonstration. Watch the setup video. Really, really helpful for this. The goal here is to be getting the kids thinking about what they might change in their own setup. So we want to be deliberate. We're going to have one control with no thermal energy added. But in our second setup where we're adding thermal energy, we want to be deliberate about just using just warm water between 100 and 110 degrees Fahrenheit and filling up the cup just halfway. This will naturally lead the kids to like, what if we make the water hotter? Or what if we add more hot water? So that's what we want to get them thinking. Here, practice with the dye ahead of time. Be prepared to do it a second time if needed. And also, as you're doing it, you want to talk through with the kids through the demo, being explicit about what you're doing with the dye. The dye part is really tricky. That same setup video also walks through tips for the student investigation piece, which is part 5. So you need just one setup per student group. They're going to compare it to condition 1 from our demonstration. So we don't need a control or a comparison at their tables. It's important that the students first fill their tub and let the water settle before they try to add the dye. Remember, the colder the water, the better. So having iced water off to the side that you can use to refill between classes is a good tip. The biggest challenge for me doing this with my students was managing the timing because groups finish at different times. So to handle this before we started, I go through what they need to do when they're finished, what's the cleanup procedure, and what's the next activity that they should immediately go start, which is drawing that group model. I also give a hard stop time. Everybody is done at the end of 15 minutes. The teacher guide provides alternate options, such as doing this as a series of class demonstrations instead. And teachers in the Facebook groups also have shared ideas around this. So good to check out. The kids do enjoy it, though. During this lesson, we'll add the words convection and fluid to our word wall. We're also going to explicitly name the movement of the air currents as either downdrafts or updrafts. And we'll continue to refer back to previous models as needed. During the end of the lesson scientist circle discussion, it's helpful to draw a class chart of what we figured out and specifically name those updrafts and downdrafts for the kids to be able to see. I hope this helps you think through how you'll approach lesson 12 in your classroom and gives you some tips to consider when planning the management of the investigation. Students are going to move on from this lesson to the final lesson of the first lesson set. So in lesson 13, they're going to develop a final model and apply their understanding to a new phenomenon. So I hope to see you in the next video.